Hello. The topic that we are going to cover today is TCP versus UDP. So let's head over to the next slide. It's talking about the agenda. So agenda is just like the previous session. We are going to cover about what is TCP IP protocol suite. Then we will be talking about the troubleshooting aspect of TCP and UDP, and then from the perspective of network security, from the perspective of cloud, and then we have some common interview question and answer as an assignment. So let's head over next slide. So this is basically talking about what is TCP and what is UDP. And if you are already familiar from your previous study that TCP and UDP reside at what layer? We have application, presentation, session layer, then we have transport layer, then we have network layer, data link, and the physical layer. So what is your guess or your knowledge about at what layer TCP and UDP works? So the answer is transport layer, which is layer number 4. Okay. So we said that at OSI TCP layer, we have two common protocols, TCP and UDP. And we also said that transport layer is used to basically transport data from one source to another uh, destination, from source to destination or destination to source. Okay, so basic idea of having this layer is to transport data. Okay, or the basic can say the functionality of these protocols basically to transport the data. Then why we are going to use these two protocols? So we are going to discuss here. TCP. So TCP meaning Transmission Control Protocol. So it stands for Transmission Control Protocol. Is a communication standard for delivering data and messages through network. So TCP is a basic standard that defines the rules of the internet and is common protocol used to deliver data in digital network communications. Whereas the UDP stand for User Datagram Protocol, refers to the protocol used for communication through the internet. So this is also used for the same purpose. It is specifically chosen for time sensitive applications like gaming, playing videos, or even the DNS lookup. So in networking, uh, in a networking, we have multiple choices. The first one is reliability, where you are worried about your data. Means this is very crucial data that you want to deliver to the destination without any error. Okay, so this is one possibility. There is another possibility. You want to transport or send data as soon as possible. Even though if there are some disruption, degradation, some noise, or no matter what it is, but you just want to send that data to the destination. Where comes the reliability? The TCP comes into play. And when we talk about as soon as possible data want to transfer, it has to do with UDP. Okay, so under TCP it is written connection oriented using three-way handshake. Okay, so this is reliable with the help of three-way handshake. And what is that? I'm going to cover in the next slide. But the drawback is it is slow because it has to go through these three-way handshake protocols, three-way handshake connectivity. So that is why it is slow. Then for reliability, it uses some methods called sequencing and acknowledgement. Then it uses some terms called windowing and positive acknowledgement with retransmission. And I'm going to discuss in the next slides. On other hand, we have UDP, and as I said that UDP we want to transfer data as soon as possible. So that is why it is connectionless. So this is the drawback, but the advantage it is fast. Okay, so let's head over to the next slide. So first of all, before I proceed for the TCP and UDP explanation, TCP IP basically is a whole suite of that makes network communication happen. So these are the OSI layer model, application layer, presentation session. Then we have transport layer, network layer, data link layer, and the physical layer. But we have another model. It is called TCP IP model or architecture. So as you can see, application, presentation, and session layer has been squeezed into one layer is called application layer. Then we have transport layer. This is like same in TCP IP suite. It's called transport layer as well. Then we have network layer, and we know that at network layer we usually use routers or the ISP connectivity, something like that. So that is why it is called internet layer, because we are going beyond our boundaries. Then we have a data link layer and physical layer. Since these both are locally significant, that is why this is called as network interface layer. Okay, so no matter this is TCP IP protocol suite or OSA model, when it comes to the protocol, sorry, no matter it's a TCP IP architecture or the OSI model layer, when it comes to TCP IP protocol suite, these are gonna reside on application layer. So these are the application like Telnet, file transfer protocol, SMTP protocol, DNS, RIP, SNMP. So these all are going to sit on at the application layer. Then the transport layer. So the current topic is TCP and UDP. You can now remember the TCP and UDP resides at transport layer. Then we have internet layer or network layer. We have IPs and EIGRP, OSPF. They basically reside on this network layer, and also ARP, ICMP, and IGMP protocol. Then in the end, physical layer or data link layer or network interface layer, we have Ethernet, token ring, frame relay, and ATM. So these kind of protocols reside at physical layer. Okay, so how TCP works basically. TCP, so before I go for the sequencing number and these things, so just look at this TCP. What happens, we have client over here and then we have a server. Let's suppose client want to access www.google.com. So before the page appears on your web browser, TCP has to make sure that the connectivity with my server is there. Or in other case, whether the server is alive or not. Okay, for that, it has to go through some process which I'm going to show you over here. As you can see over here, let it play again, then I can stop. So the first step, as you can see, this is a client and this is a server. Client basically is going to sync, so it is going to send a synchronization to the server. So sync sent, sync received. Okay, so synchronization is the process to tell the server that I want to talk with you. Similarly, server is going to reply back with the acknowledgement plus sync. You know, not only the client wants to communicate with the server, But also server will also send the synchronization back that I also want to talk to the client. Then the establishment will happen. So as you can see, the connection has been established, and in the end, you can see the final acknowledgement has been sent back to the server saying that, okay, if you agree to talk with me, or I'm also agree to talk with you. So the connection has been established. So this is where after that, let it finish. So once the connection has been established, then from there onward, the data will be transferred from the server to the client. Like it is going to send the image of Google, it is going to send some text, it is going to send some forms, okay, and the client is going to reply back with the acknowledgement. Okay, I got it. I got the image, I got the text, I got the form, I got this video, I got this text, I got this URL. Okay, so it is going to acknowledge back. So this is the whole process happens between client and server. So basically, uh, first packet will be sent by the client is sync. Server will send back sync plus ACK. So this ACK is going to relevant with this sync. But this sync is the new synchronization that server wants to uh, basically connect with the client. So in the end, client is going to send back the acknowledgement. Then the data will be transferred with the acknowledgement. Okay, so this is all happens in the TCP. Most common flags that are being used are sync flag, finish, and acknowledgement. Sync, as it is stated, that initiates a connection. Acknowledgement is acknowledge receive the data, whereas the fin, which is final flag, cleanly terminates a connection. So once all the data has been transferred, in the end there is going to be a fin bit finish. So I'm going to finish this, you know, the transmission. So as you can see, request connection sent, confirm connection, request data, and send data. So this is the whole story is happening in the TCP. Opposed to TCP, we have UDP that also work in the same fashion. Request data, but as you can see, clearly see, it is asking for the connection first. Then it is going to request the data. So it has one step and second step. Whereas in case of UDP, it just started to get data. It is started to request for the data. It send data, request data, send data. And here we have acknowledgements here as well. And there UDP, there is no any kind of acknowledgements because we want to travel data as soon as possible. So in the first paragraph, it is saying that TCP utilize a number of flags, and these are the flags which I'm talking about, or one bit Boolean fields. It could be sync, or it is mentioned that sync is equal 1. If it is 1, it means it has synchronized. If it is 0, it means it is not synchronized. Okay, so this is what Boolean field means. In its header to control the state of connection. And when I will show you the header of the TCP, you will see the flag options there. The three we are most interested in here, these are the sync, fin, and ACK. So how to TCP and UDP work? So this is going to be a differentiated table between TCP and UDP. So first TCP. TCP creates a connection between two devices, and we have already I have already demonstrated you. So it's establish a connection first. But UDP sends data without connection. In a second step, break a data into packets with the sequence numbers, which we are going to cover in the next slide. Whereas in UDP also, breaks the data into packet but does not assign a sequence number. So it just sent blindly. Sends packets and wait for the acknowledgement. Whereas in the UDP case, sends packets without waiting for the acknowledgement. Resend lost packets to make sure all data is received. Whereas it doesn't care. It doesn't care. Gets data packets in the correct order, whereas deliver packet as they arrive, which may be out of order. So now you might be wondering where we need TCP and where we use UDP. If I will give you UDP example, for example, you are going to make a call using voice over IP. Voice over IP basically going to use, or even the Zoom calls, Zoom or Teams meeting calls. Okay, when you are communicating or doing a conversation over VoIP or Zoom, sometime what happens, you are speaking, let's say you are saying hello, my name is Kamran, but you missed some packet and you said hello, my name Kamran is has been lost, but the receiver does not care because he got the idea. Okay, he got the idea that what I am trying to say. So that is why where uh, where we have to send the data as soon as possible. In case of voice over IP, video, Zoom meetings, Teams, we are going to use UDP. But where we need the confirmation, let's suppose you are using some like job skill share website, which is using some kind of SSL and TLS protocols, which are secure, okay, or HTTPS. It means whatever the piece of information you are receiving from job skill share is going to be acknowledged by my PC. If some packets are missing, I will request that web server kindly send me that image. For example, I lost some image data. I will send that sequence number back to uh, my server saying that kindly send me that information back to me. So once it will send back, then my next communication will happen. So that is why this is slow and this is fast. I hope you got the idea. So let's start up with the next slide, which is talking about the one of the most important aspect when it comes to TCP is called sequencing and acknowledgement. So these numbers help enable order reliable data transfer for TCP streams. The sequence number is sent by the TCP client, indicating how much data has been sent for the session, also known as the byte order number. The ACK number is sent by the TCP server, indicating that it has received cumulative data and is ready for the next segment. So if you will just, I have given you the example here. For example, this is my client machine, this is PC, and this is the server. And I am trying to basically access some website like jobskillshare.org. As soon as I type this URL, hit enter, what is going to happen? First of all, it will go through the three-way handshake process, which we have already discussed. It will send the sync packet, then server will send the sync plus ACK or ACK sync, and the response will be sent as ACK, and the data will start to transfer. So this is where sequence number and acknowledgement numbers comes into play. Let's suppose the sender initiated with a sequence number of 100 that I am looking for this information. It will be received by the server. It will be received by the server. And if it received, it will say, I'm going to send back your acknowledgement or your sequence number plus 1 having my acknowledgement. So this is always going to be sequence number plus 1, which is 101 back. But on other hand, server also want to sync back or will send the sequencing that whether you have received my data or not. So it is going to send the sequence number 50. Again, sequence number plus 1 is going to be my acknowledgement. So this is the acknowledgement of this sequence number. Whereas on other hand, after acknowledging 101 back to the client, the client is going to send a sequence number 101 and acknowledgement number 51. Once this server will receive sequencing number 101 and acknowledgement number 51, as you can see, it is going to increase sequence 101 plus 1, which is 102. And similarly, 51 will be incremented to 52. So as you can see, these numbers are increasing sequentially in a order. It is not like that it sent 10 and it is going to acknowledge with 200. No. Otherwise, there is no communication. Otherwise, it is going to ask again, kindly send me sequence number 100. Oh, okay. So basically, for example, if it send the packet sequence number 101 and 101 is lost, it is going to send back with the acknowledgement number 101 saying that I haven't received sequence number 101. Kindly send me 101 back. I hope you get the idea. So let's head over to the next slide, which is talking about the TCP windowing and sliding window. So let's first read about the paragraph. TCP uses windowing, which means that the sender will send one or more data segment and the receiver will acknowledge one or all segments. When we start a TCP connection, the host will use a receive buffer where we temporarily store the data before the application can process it. If the traffic does not appear within some hold off period, it will re-act the last segment it received. This all well documented TCP processing. But read, use any search engine or visit a bookstore. Okay, so if you want to get more information, kindly search through the Google engine or from any bookstores. And I will recommend if you are familiar with TCP IP, uh, this is the book name TCP IP uh, 2. We have PDF format available online. You can download and you can study about it. So basically what it is trying to say over here, TCP windowing and sliding. Just taking the same previous scenario, sequence 100 is sent, acknowledgement with the 101, now it is going to send its own sequence number as well. But on the basis of capacity, on the basis of capacity of this receiver, which is going to be a web server. So first it sent one packet. It acknowledged, yes, I received. Now this time you can see it send one, two packets, and it acknowledged with 103. Means it is saying I need more. I need more. So in the third step, once it sent sequence number 103, 104, and 105. Now this time it sent three packets. Now you can see this packet has been dropped, 105. It asked again for the sequence number 105. Now it is going to send again sequence number 105 and it is going to acknowledgement with 106. So what is happening here basically? If, as you can see, I have shown a picture of a juggler. So what juggler basically do it, he uh, play with these balls. Okay, initially he starts with two balls, so he's juggling these two balls, juggling, juggling, juggling. Then he add another ball because he has a good capacity to handle three balls. So third ball is also included. Then he added fourth ball, then it started working normally for him. Then he added fifth ball and it is working fine for him. So as you can see, one, two, three, four, five. So five balls he can handle accurately. As soon as you added another sixth ball, these all other balls will be dropped, or he will not be able to handle those balls. Okay, so just imagine these are the packets or sequence number, and this is your web server. He is handling two or three packets, and you as a client sending more balls as a packet. You will send one packet, one ball, and will see. So I'm going to draw it again. This is client and this is your server. First, you started with one ball. You just throw a ball to him and he start playing, and he is playing very well. Then you added another ball, two balls. He started to playing. Then three, then four. When you hit the fifth ball, he start to face the problems. It means your web server have a capacity to handle only four balls. Okay, this is very, very, very layman example, but just to make you understand. So this is what is called TCP windowing. Windowing size is they are going to, let's suppose they are saying I can handle 10 balls. So this is the windowing size will be set by who? The server. Server will say let's start hand from the first one ball first. So as soon as the communication start happening 2, 3, 4, 5, 6, 7, and 9, now the ball is set to 10. So it means maximum window size it can handle is 10, 10 balls. It cannot go beyond that. So our communication will remain in between 1 to 10. So maybe sometime the packets will be sent, three packets will be sent, four packets will be sent, six packets will be sent, seven, eight, nine, and then it will come back again to four packets, three packets. And randomly, maybe in between, it will start to send the 11th packet and will check if it is dropped or not. If it is dropped, it will come back to the. So that is called windowing. And the sliding window also. So sliding window has to do with windowing. Once you have set the window size 10, now the client over here will try to add another ball. He will try to add another ball to check whether this he can handle or no. This thing is called sliding window. So it can be increased or decreased as well. So I hope you get the idea. So let's head over to the next slide, which is talking about the port numbers, port number protocol and usage. So I will be hammering these concept again and again on your head because these are the very important and crucial aspects when it comes to the networking. Port numbers, protocol, and usage. Port number 20 is, you can see, when we say TCP IP, TCP IP is just not a protocol. It's a protocol suite. It has many sub protocols like FTP. FTP you can see comes under TCP. Then FTP has two, by the way, port number 20 and 21, and I have already discussed. So the both FTP comes under TCP. Secure shell comes under TCP. Telnet comes under TCP. SMTP comes under TCP. DNS system comes under TCP as well as UDP. So this is also going to be very important interview questions. So DNS works for both UDP as well as TCP. Then dynamic host DHCP. I will be covering DHCP a lot in detail, but just for the timing, I'm just going to give you idea. The DHCP server, when you get some IP, automatically it is going to use UDP, and it is going to use two port number 67. It is for the server, and 68 is for the client. Trivial file transfer protocol. Usually, most of the time, Cisco using TFTP.